There's a couple of ways of doing this. The first way is just to spot that it's a polynomial and therefore factorise it, so it's x squared times 1 plus x, which means it passes through the origin and it passes through minus 1, and we know it's got to be large, and we know that it has to just touch the axis for x equals 0 because it's a squared there, so it looks like that. Another fun way of doing this, which is something I do with students starting out with graphs, that maybe they've just, if they're looking for a more advanced questions to test their ability to think graphs through, I like to use this one before they're really used to factorising. We can work out these 2 points here because I get them to try. So I'll tell the student, why don't you try x equals minus 1, what happens? Well, if x equals minus 1, it turns out to be 0, so it passes through that point there. And then I'll suggest trying x equals 0, and then that passes through that point there. So then the next question is, well, what happens otherwise? Well, let's draw x squared, and let's draw x cubed. X squared graph looks like that, x cubed graph looks like that. So it seems pretty obvious to me that it's going to curve up to the right for positive x, because you're just adding two curves that curve up to the right. Now eventually it must go down here. What happens in the meanwhile? Let me just redraw that. Well, if you cube a number, we've got a competition here, which is you've got an x squared and you've got an x cubed. So for negative x, the x squared is trying to make it positive, and the x cubed is trying to make it negative. The x cubed eventually wins, hence I've already drawn this line going down this way, because x cubed will ultimately be bigger. But if you cube a number between minus 1 and 0, so in here, if you cube it, you actually make it smaller, because every time you multiply a fraction together it gets smaller and smaller. So the x squared briefly wins in this section. So in this section here, x squared and x cubed are doing the same. In this section here, x squared wins, because if you times a fraction repeatedly it gets smaller and smaller, so the x cubed hasn't made it as small. And in this section, and obviously off forever in that direction, the x cubed wins, because if you cube a number, it's going to make it a larger magnitude than squaring it. Maybe that was useful, maybe that was just really confusing. Apologies if it was really confusing. But you can always just go back to the original method, which was here, which was we just treat it as a polynomial, factorise it, and you can sketch a graph.